with all of those rational functions that you looked at, there were some things that were similar about them. Things like asymptotes you see often with rational functions. And the ones that have the most in common are the ones that are the same type in terms of their degree. So the first ones you looked at was where the numerator degree was less than the denominator degree. And what you find out is that they all have a horizontal asymptote at y equals 0. So anytime that the degree on the top is smaller than the degree on the bottom, so like you have an x over an x squared or an x squared over an x cubed, something like that, you'll have a horizontal asymptote at y equals 0. And the x-intercepts correspond to factors of the numerator only, which means if they're a factor of the numerator but not a factor of the denominator, then you'll get an x-intercept. So we saw that in quite a few of those examples that you looked at. But one thing that we talked about vertical asymptotes at the non-permissible values of the rational function. So the factors in the denominator, those tell you your non-permissible values. Those tell you where your vertical asymptotes are. But this other thing we didn't talk about yet is the point of discontinuity. Sometimes you don't have a vertical asymptote. Sometimes you have what's called a point of discontinuity. And that's actually when you have the same factor in the numerator and the denominator. So if you look at this example, y equals x plus 1 over x plus 1 times x minus 3, well, that's the same as 1 over x minus 3 when x cannot equal negative 1 or 3, because those are the non-permissible values, right? Negative 1 and 3. So that's where you would expect to see vertical asymptotes. But when you graph that, you actually only get one vertical asymptote. Because that factor canceled out, it changes into this function 1 over x minus 3 that only has one vertical asymptote, but it has a point of discontinuity, which is where basically it's like a hole in the graph. Can you see that little hole in the graph there? There would be an asymptote there, except that that factor canceled out, so it leaves that point of discontinuity. Here's the other type that you have to consider. When the numerator degree is equal to the denominator degree. That's what you had on the back of the page, right? Like an x squared over an x squared? Or an x over an x? I think that's what it was. Here, the horizontal asymptote is not at y equals 0. It's the leading coefficient of the numerator divided by the leading coefficient of the denominator, which is what Mitchell told us. Because the first one, I think it had 2x over 3x. So it was at 2 over 3. This one has 2x over 3x. The lead coefficient here is 2. The lead coefficient here is 3. So 2 over 3, that's where you find that horizontal asymptote. You have to be careful if you're in factored form. If you have two factors, you need to multiply the x's together to figure out what the lead coefficient will be. But that's how you find that. And then the vertical asymptote, same as the first one at the non-permissible values of the rational function. So where the factors in the denominator are equal to 0. So the value of x that makes the denominator equal to 0. So in this case, negative 1/3 is where that is. And that's kind of all you have to know about that one. So I also put this here. I just took a picture of your textbook because this is in your textbook where it's all summarized, and this is on page 451 in your book. So some key ideas. The graph of a rational function has either a vertical asymptote or a point of discontinuity corresponding to each of its non-permissible values. No matter what, if the degree in the numerator is the same or if it's less, that's always the case. Vertical asymptote or a point of discontinuity corresponding to each of its non-permissible values. But here's my question for you. How do you know when it's a vertical asymptote or when it's a point of discontinuity? If it cancels out with one of the factors in the numerator, right. Or it could have no vertical asymptotes or points of discontinuity if it has no non-permissible values. Which you did see on that sheet, one that didn't have any non-permissible values, and then it doesn't have any vertical asymptotes or points of discontinuity. To find any x-intercepts, points of discontinuity, and vertical asymptotes of a rational function, analyze the numerator and the denominator. So you're going to look at the numerator in factored form and the denominator in factored form. A factor of only the numerator corresponds to an x-intercept. A factor of only the denominator corresponds to a vertical asymptote, but a factor of both the numerator and the denominator, those are the ones that cancel out, those are the ones that correspond to a point of discontinuity. And then it says you can use a table of values or the graph to figure out more about it.